Myself Dr. P.R. Krishnavini. Welcome to the lecture on petrol knocking. In the earlier video, we had discussed about reforming of gasoline. In this video, we will discuss about knocking of petrol. So, coming to knocking. Knocking is defined as the metallic sound similar to rattling of hammer produced in internal combustion engine due to immature ignition of fuel air mixture. The internal combustion engine converts the chemical energy into useful mechanical energy by burning fuel. An internal combustion engine uses either gasoline or diesel as fuel. The ignition is brought by means of electric spark or by compressing the air. So, if ignition is brought by means of electric spark, it is brought in the case of petrol engine. Ignition is brought by compressing the air in diesel engine. Next, the gas produced during ignition forces the piston down due to high pressure, thus producing power stroke. You can better understand about this power stroke after learning about the working of internal combustion engine. So, now we will discuss about the working of internal combustion engine. Here we will discuss about the 4-stroke internal combustion engine. So, the internal combustion engine mainly consists of a spark plug, intake valve, exhaust valve, air fuel mixture, combustion chamber, this is the piston, and this is the connecting rod, and this is the crankshaft. So, here the 4 strokes are intake stroke, compression stroke, power stroke, and exhaust stroke. So, the first stroke is intake stroke. This intake stroke can also be called as induction stroke. In this stroke, air fuel mixture is drawn in. How air fuel mixture is drawn in means, first the piston will be moving down from top to bottom. The intake valve is opened, and through this valve air fuel mixture will be passed into the cylinder by atmosphere. Next, the intake valve will be closed, and the second stroke is compression stroke. In this stroke, air fuel mixture is compressed. In this stroke, both intake valve and exhaust valve, these two valves are closed. So, this is the intake valve, this is the exhaust valve, these two valves are closed. And now, the piston will be moving from bottom to top, thereby compressing the fuel air mixture. Due to this compression, the temperature of air fuel mixture will rises by several hundred degrees. So, here temperature rises. By several hundred degrees. Next, third one is the power stroke. In this stroke, here the piston will be moving from top to bottom. Why this piston will be moved means, here the fuel air mixture, this will be ignited using the spark plug which is present at the top dead center. So due to this ignition, the pressure developed will push the piston from top to bottom. Next, last stroke is the exhaust stroke. In this exhaust stroke, the piston will be again moving from bottom to top. The exhaust valve will be opened, and here the air fuel mixture burnt gases will be sent out. This is how the internal combustion engine will be working. The efficiency of the internal combustion engine depends on compression ratio. So, compression ratio. Compression ratio means it is the ratio of gaseous volume in the cylinder at the end of suction stroke to the volume of gas at the end of compression stroke. This is called as the compression ratio. Higher the compression ratio, greater is the efficiency of the engine. To achieve maximum efficiency, a compression ratio of about 7 to 8 is required. If compression ratio exceeds certain limit, it results in pre-ignition of the fuel. The pre-ignition of the fuel and air mixture at the compression end of the cylinder in petrol engine produces a large thumping sound called petrol knocking. Now coming to the factors affecting knocking. The first factor is design of the engine. Second one, it depends on the operating conditions of the engine. Third one, chemical structure of hydrocarbon in the fuel. So coming to the chemical structure. First one, knocking increases with increase in length of hydrocarbon chain. So knocking increases with increase in length of the hydrocarbon chain means, for example, if you take N-butane, knocking of N-butane is less than N-pentane, which is less than N-hexane, which is less than N-heptane. That means knocking will be increasing with increase in length of the hydrocarbon chain. Next one, knocking decreases with increase in branching. So here what we are saying, knocking of N-heptane is high when compared to the remaining lower hydrocarbons. So, knocking of N-heptane is greater than 2-methylhexane. Y means same number of carbon atoms, but here branching is there, which has more knocking than 2,2-dimethyl pentane. And third one, knocking decreases with increase in double bonds and rings. If you take aromatic compounds, like benzene or toluene, these will have very high anti-knocking properties. As here I told you, knocking decreases with increase in double bonds and rings. So, aromatic compounds means they will be having alternative double bonds. So, that is why their knocking it decreases means what? It will have very high anti-knocking properties. So, if you observe the general tendency, of knocking, knocking of straight chain hydrocarbons is greater than branched chain hydrocarbons, greater than olefins, greater than cycloparaffins, and the least will be for aromatic compounds. This is the general tendency of knocking. Octane number or octane rating. The extent of knocking can be measured by using an arbitrary scale called octane number or octane rating. It is observed that N-heptane knocks very badly, hence anti-knock value arbitrarily assigned as 0. Isooctane has high resistance to knocking, hence anti-knock value arbitrarily assigned as 100. So, coming to N-heptane. N-heptane means CH3, CH2, 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 CH3. So, this is N-heptane. So, it knocks very badly, hence the anti-knocking value is arbitrarily assigned as 0. That means octane number of this one is assigned as 0. And octane, isooctane means CH3, 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 CH2, CH3, So this is called isooctane. It has high resistance to knocking, hence anti-knocking arbitrarily assigned as 100. That means octane number of isooctane is assigned as 100. So this is the isooctane. Octane number of a fuel is defined as the percentage of isooctane in a mixture of isooctane and N-heptane which has the same knocking characteristics as that of fuel under examination under same set of conditions. Anti-knocking agents. The anti-knocking properties of gasoline are usually increased by adding tetraethyl lead. So the process of addition of tetraethyl lead, this process is called as doping. So coming to tetraethyl lead. Tetraethyl lead is a colorless liquid which has sweet smell but highly poisonous. .5 ml of tetraethyl lead per liter is added for motor fuels. On ignition, tetraethyl lead undergoes combustion in internal combustion engine and converted to lead peroxide which reacts with any hydrocarbon molecule, thereby slowing down the chain reaction of pre-ignition. There is a disadvantage with tetraethyl lead. What is the disadvantage means? Lead peroxide which is deposited in internal combustion engine. This is harmful. So this is the disadvantage associated with the addition of tetraethyl lead to gasoline. To overcome this problem, ethylene dibromide is added which converts lead peroxide to volatile bromide which escapes into atmosphere. Unleaded petrol. To overcome the problems of lead, unleaded petrol is being used nowadays. It is the one whose octane number is increased without the addition of lead compounds. High octane number compounds like isopentane, ethyl benzene, isooctane, methyl tertiary butyl ether are used. Nowadays, methyl tertiary butyl ether is more preferable. Why means it contains oxygen in the form of ether group and this will supply or the oxygen can be used for combustion of fuel. As a result, it avoids the formation of peroxy compounds. So this is the advantage of using methyl tertiary butyl ether. Use of unleaded petrol requires use of catalytic converter. Here catalytic converter means It contains rhodium as catalyst. Rhodium will convert toxic gases like CO and NO into harmless gases like CO2 and N2. Another advantage of rhodium catalyst is it oxidizes unburnt hydrocarbons into CO2 and H2O. Thank you.